My name is Jingbo Yan, and this is my coworker Benjamin Jaeger. Today we'll talk about multi-threaded rendering on Android with two open source libraries, Litho and Infer. So first we'll talk about why traditionally Android has been UI only. And then we'll introduce Litho, a declarative UI framework, and how it helps support multi-threaded rendering. Next, we'll discuss about thread safety, where concurrency issues can be hiding, and how Infer static analyzer can help find those bugs. And finally, we'll conclude with what we got and what we learned when we use Litho and Infer to make Android newsfeed multi-threaded rendering. So let's start with some historical context on multi-threaded UIs. In 2004, Graham Hamilton, a VP at Sun, have said multi-threaded GUI toolkit seems to be one of the failed dreams. He didn't see a way to make Swing and AWT GUI framework multi-threaded without running into large amount of deadlocks and thread safety issues. Around the same time, Android is being developed, and its UI toolkit is also single-threaded. In the Android developer guide, it says Android UI toolkit is not thread safe. And at the end, it's also said, do not access Android UI toolkits from outside the UI thread. However, a few years later, async UI framework actually started being a thing for iOS. One of it at 2015 is Component Kit, built by Facebook to power the Facebook iOS newsfeed, and now is used throughout the Facebook iOS app. So after seeing its benefit on iOS, we want to do something similar on Android too. And we did manage to make to achieve multi-threaded rendering on Android and on a large-scale surface, Facebook newsfeed Android. So that's how today we'll talk about how we moved Facebook Android newsfeed rendering to a background thread by and improving scrolling performance. Originally, Facebook newsfeed is also built using standard Android wheels. But just recently, we updated all newsfeed to use the Litho framework. However, the rendering are all still based on UI thread, and that's because there were still legacy code that were not thread safe. So we fixed all the thread safety issue, and as a result, we did manage to safely convert Facebook newsfeed to multi-threaded rendering with a scroll performance improvement. So before I get into more about Litho, let's first talk about the traditional Android wheels and why is it always been single-threaded. So here's an example of a simple hierarchy with an image and two lines of text. So how do we render it on Android usually? We render it, one of the common way is to render with nested wheels with like linear layouts and image wheel and text wheels. And what makes it not thread safe is, for example, text wheel have a method called setText that mutate a field called mtext. So Android wheels are mutable and stateful. And the problem of this is if, for example, you mutate mtext on a background thread, you could run into issues like part of the UI thread rendering is performed based on former mtext and part of it performed based on later mtext. This could cause severe behavior issues. And not to say text fields have many other states like mtext color, and there could be much more different kinds of potential thread safety issues involved when it involves mutable states. So Android wheels are in general stateful and mutable. Not just text wheel, like linear layouts and image wheels, they all have their own mutable states. And that's why, in general, wheels are, as mentioned before, only recommended to be accessed on UI thread. So what it means performance-wise is, because wheels can only be accessed on the UI thread, everything related to it need to be run on UI thread, and UI thread can frequently be overloaded. So for an example, for your recycler view or list view, when you have a new child item scrolls onto the screen, you need to create the nested view, bind data to it like set text, and measure it and draw. And all these are related to views, so need to be run on UI thread. This could make it pretty difficult to not skip a frame, especially when there is only 16.7 milliseconds to render a frame. Here's a side-by-side comparison of a smooth scrolling experience on the left and a stuttery scrolling experience on the right with lower frames per second. Yeah, the right one even finished a bit later because it stuck a little bit in the middle because of the lower frames per second. So as you can see, the user experience on the right is not as good, and that's why we work hard to improve scrolling performance. We want to avoid overloading the UI thread and skip as little frames as possible to achieve a smooth and natural scrolling experience like on the left. And next, I'll introduce Litho and how it helps support multi-threaded rendering. So for the same image and text hierarchy mentioned before, Litho separates into two separate parts, a simple Litho wheel that's a wrapper and a tree of components. The tree of components contains content and position of the image and text elements. And it's also thread safe, so it could be pre-populated and prepared on the background thread beforehand. On the other hand, the Litho wheel is still an Android wheel, so it needs to be run on the UI thread, but it's also just a simple wrapper, so it's lightweight and efficient to render. Once both the tree of components and the Litho wheel is ready, we then mount the tree of component to the Litho wheel when the item reaches the viewport. The hosting Litho wheel will visualize all contents of the tree according to the information stored in the tree. So this process is a view mutation, so it needs to run on UI thread, but it's also efficient because all the content and position information is already stored in the tree. And that's how we separate the heavy computation from the Android UI framework to the Litho framework and no longer restricted to UI thread. To give a better idea of what this tree of component thing is, we'll talk about an individual node in the tree, a component. A component is a function that takes input, which Litho called them props, and return a component hierarchy describing the UI. So the way to define a component is by declaring a spec and annotated with corresponding annotation. Then Litho use annotation processor to generate the component instead of letting you write the whole thing. This is how it keeps the error prone and stateful part of the code internal to the framework. So for the example, for our my component, you need to declare my component spec and annotate it with layout spec. You also need to make a layout method and annotate it with onCreate layout, and eventually use add prop for all the input params so that the generated my components can accept drawable, title, and subtitle as input. Now let's get into the actual layout code. This is a code that defines what hierarchy to build given what input. This will provide widgets like image, text, row, column, and many others, which make it easy for you to define your hierarchy using a builder pattern and in a functional way. So for our case, we just need a row that contains an image and a column, and the column contains two text to define the image and two lines of text. And this is just a very simple example without much details like paddings and events. And Litho actually supports much more complex UIs, and you can see more example in their documentation. After the annotation processor runs, we now have the My component generated and ready to use. And by applying params like drawable, title, and subtitle to it, we've now built a very simple trio of components. So next is, as mentioned before, we mount the trio of components to the Litho wheel, where the hosting Litho wheel will visualize the content. One of the ways to do that, there's many ways to do that, depends on how much customization you want. One of the simple way to do that is by applying the component to the Litho wheel.create. And the hosting Litho wheel will lay out the trio of components, which then will be ready to use in your application as you would normally use an Android wheel. So now that you have an idea of what the component is, how does it help performance? How does it help multi-threaded rendering? Litho called this process background layout. One of the way they provide is a utility called recycler binder. Similar to a recycler view. The recycler binder helps handle the scrolling of child items onto the screen. But on the other hand, it also helps posting computationally expensive work like pre-calculating the component to the background thread before the item reaches the viewport. So when the item do reach the viewport, the only thing you need to do is you create a lightweight Litho wheel. You mount a pre-calculated component to it and draw. This is much more efficient than create the nested wheel, bind data to it, measure it, and then draw. And therefore, as a result, it's much more likely to finish a frame within 16.7 milliseconds and avoid skipping a frame. Yeah, so that's how it helps improve scrolling performance. And so that's about it for what the Litho is and how it's stress safe and how it helps improve scrolling performance. So if you are interested in seeing more examples, do check out their documentation if you're interested. We sincerely hope more of the Android work can benefit from it and improve user experience and scrolling performance. So now let's pass it back to my coworker Benjamin for Java concurrency and the Infer static analyzer.
All right, thank you. So Jingbo just talked about the Litho framework and how it supports background layout. And now I'd like to talk about how we got background layout working in Newsfeed. So we faced two major challenges getting Newsfeed to run with background layout. And the first is that we needed to make large amounts of code thread safe. So the picture on the right depicts the basic Litho hierarchy for a story in Newsfeed. As you can see, there's like a story spec, a title, content, network, et cetera, specs for all that. And but in reality, it gets much more complex. And there's actually thousands of Litho specs and delegates in our code base. And then each of those specs have their associated delegates and dependency classes. And then another thing we have to think about is that Newsfeed was originally implemented with the Android view system, and so it was UI only. And that means that there could be race conditions hiding anywhere in the code base. There's still places that expect to operate on the UI thread and aren't going to behave well when they become multi-threaded. So overall, there's simply too much code for Jingbo and I to read through it all, looking for race conditions. And even if we could read through the code, we'd probably make mistakes and miss finding bugs. The second challenge that we faced is once we got feed running with background layout, it needs to stay bug-free. The reason being that adding threading to the rendering pipeline significantly increases the complexity of the code base. And we don't want to have a code base where it's easy for developers to create new bugs or regressions. There's hundreds of Android developers working on the Facebook app, and we can't guarantee that they're always going to be on the lookout for concurrency bugs. So all in all, we need to be pretty careful when implementing background layout. And yeah, I like to think that this picture is a bunch of Facebook developers after they found a concurrency bug. So to give an example of what it's like to look for race conditions in the code base, I have the following sample code. And the question is, do you think that this method getPy is actually thread safe? And if anyone knows the answer, you can raise your hand. Yeah. Yeah, that's correct. Do you know why? Yeah, that's correct. So all Android devices, as far as I know, are 32-bit VMs. And so that means that reads and writes to doubles and also longs are not going to be atomic. So in other words, it's going to take 2 CPU operations to write to MPy. So to show where this becomes a problem, suppose you have 2 threads. And on the first cycle, thread 1 is going to call getPy and MPy 0, so it goes on to calling fetchConst. And the first thing it's going to do is write half of MPy. And then for whatever reason, the system decides to suspend thread 1. Thread 2 starts running, and the first thing it's going to do is check the value of MPy. So it reads half of it, reads the second half. It's not 0, so then it returns. And then the next cycle, thread 1 starts up again, finishes writing. And the problem, though, is that when thread 2 read the upper half of MPy, there was just a garbage value. And so it returned with an invalid result. One way to fix this would be to make MPy volatile, which is a keyword indicating to the VM that reads and writes should be atomic to MPy. But the overall point that I want to make here is that determining thread safety, even for small code fragments, is not always straightforward, and it definitely gets more complex as the code base gets larger. So concurrency is hard. I don't think anyone will disagree with this statement, but to break it down a little bit, it's hard to analyze the code and determine whether pieces are thread safe. That's what we just saw. It's difficult to debug. For example, you could receive a stack trace from production, and it could be caused by a race condition, but it's pretty unlikely that you'll be able to reproduce those conditions locally because race conditions happen with a low probability. And then sometimes there's no stack trace at all. Race conditions can cause undefined behavior and not crash the app. So that's what we have here, where the background resource for a button got replaced with angry faces. This was just in a pre-release employee-only version of the app, but it's definitely something that you don't want to happen. So with those challenges in mind, I'd like to return to Litho, the framework that feed is written in, and discuss how it simplifies thread safety. And the good news is that Litho, if used in a completely functional way, is inherently thread safe. That's the functional programming paradigm. So as long as you keep your specs functional, you don't have to think about the threading model at all. And to follow functional programming 100%, all the state in your UI must be managed through the Litho APIs. So this example shows a counter that gets incremented every time the UI is clicked. And I don't have time to go over all the API in detail, but the basic idea is that the state update is described as a bunch of functions. And if you're writing a UI completely from scratch, then it's pretty easy to follow this rule of 100% functional programming. I just have to stick to using these APIs. On the other hand, when you're converting an existing UI, and that's what we were doing with Newsfeed, then there's most likely going to be lots of legacy code that is full of unmanaged state, and that puts you at risk of concurrency issues. So the challenge then becomes finding all these instances of state and ensuring that they are thread safe. There's a few different ways that specs can become stateful and thus not be thread safe. The first is through spec field members, such as mRendered in this example. And the problem is that onCreateLayout can be called either on the background thread or on the UI thread, depending on whether the render is done eagerly or on demand. And that means that mRendered could potentially be accessed by 2 concurrent calls, and so that would be a problem. The recommended way to fix this would be to use the Litho state APIs, but again, sometimes if the example is more complex, that could be difficult. So you'd have to make sure that access to mrendered is locked down, like by using the Java synchronized keyword. And then other ways that unsafe patterns can enter into a spec is through external methods and mutable props. So in this case, we have m-injected that should render and mutable props that should render. And ideally, all mutable props should be, or all props should be immutable, and all external methods should be functional. But again, if the code is more complex, you're taking a large legacy dependency, then you have to ensure that those things are thread safe as well. So as I just said, Litho, with its functional programming model, goes a long way to getting us safe multi-threaded rendering. But on large existing surfaces like newsfeed, there will still be many instances that don't follow the functional programming model 100%. And this leaves the code vulnerable to multi-threading bugs. And as we saw, this class of bugs can be both difficult to find and also pretty difficult to fix. So fortunately, there is another open source project that can help us, and that's the Infer static analyzer. Infer is an open source tool developed by Facebook, and it can detect bugs in code before that code runs in production. And this is pretty beneficial since by the time a bug reaches production, it's too late. Once a buggy version of the app is out in the wild, there's always going to be some fraction of people that never update the app, and they're always going to have this bug. And also, of course, crashes in general are just a bad experience. So one thing to keep in mind when thinking about Infer is that as a static analyzer, it doesn't actually execute any Android code. The analogy I have, the thing about this is it's kind of like a chef that can look at a recipe and determine whether the recipe is tasty or not without actually cooking it. And so the different things that Infer can look for are, you can check for null pointer exceptions, resource leaks, and then the analysis that was just recently added is concurrency race conditions, and that's what we used. So what exactly do I mean when I say that Infer can check for concurrency? It's actually quite different than how us humans would analyze code. So Infer, at least in its current incarnation, has no specific knowledge of Java threads. It just simply makes the assumption that any public method can be, or not private method, can be invoked concurrently on any thread. And then it's going to warn whenever it sees two conflicting accesses to the same object field. And a conflicting axis is defined as a write that races with another write, or a write that races with another read. So in this example, we have the class dinner. It's annotated with @threadSafe. That signifies to Infer that it should check the class for concurrency. And even though there's no calls to new thread.run, that's how you create a new Java thread, it's going to assume that makeDinner, the public method, could be called on two threads concurrently. And then Infer is going to follow the call chain to boil water, and then it will see that mTemperature could have conflicting writes. So once Infer detects that mTemperature will have conflicting writes, it generates an error report highlighting the unsafe accesses and the associated call chain. And this is pretty useful. Like the previous example was simple, but these call chains can get pretty complex when they go through multiple files and objects and if else branches. And so yeah, the way to fix the example that we just saw would be to either synchronize the boil water method or to make mTemperature volatile. So the amazing part of Infer is that it can analyze any size code base for race conditions, and it can also quickly return the results for that analysis and on every code change that a developer makes. So we ran Infer on the entire set of Litho specs in our code base before enabling background layout, so that helped us find all of the existing issues. And then we configured Infer to run continuously on all future code changes, both on classes that are annotated as @threadSafe and also all of the Litho specs in our code base. So in the past 6 months that the concurrency checks have been running, we've seen over 700 reports that have been fixed. And the way that this works is when a developer creates a code change in our tool Fabricator, Infer will start running, and then with a P75 of around 25 minutes, if it thinks that there's an issue, it will comment right on the line of code that has the problem. And how does Infer work? This will be kind of a basic explanation since I'm not a static analyzer researcher, but for every method in the code base, Infer computes a summary containing all the necessary information to run the analysis. And one of the main things in the... Oh, put the log back in. So one of the main things in this summary are the call chain, the callees of every method. And so as Infer runs through the code base, it's able to build up a giant graph of all the different possible call chains in the code base. And computing these summaries is resource intensive, so Infer caches them. And then whenever the code changes, then Infer only needs to run and create summaries for the part of the code that changed. And so that's part of what makes it so fast. And so inside the summary, there's the possible call chain of how to reach that method, the different locks that might be held, and this concept of ownership, which is kind of similar to unique pointers in C++, if you're familiar with that. And then also, as I mentioned, all the callees. So Infer is going to use all this information in order to look for conflicting write and read accesses, and also to generate the reports. So this was a pretty fast introduction to Infer. There's definitely more things to cover, but just want to go over the limitations. First off, Infer is a bug finder, not a prover, so that means that there's both going to be false negatives, and that means that there's a concurrency bug that Infer misses, and then there will also be false positives, which is that Infer reports an issue that's not actually a bug. So to help with the false positives, we have an annotation API that can feed assumptions into the analysis. So in this case, the method run is being executed by, on a UI executor, so we know it's going to be only ever running on the UI thread. So it gets annotated with that thread confined, and that will tell Infer not to assume that it's being called on any thread. And now I'll hand it back to Jingbo to talk about our results in newsfeed.
Okay. Stop working? Okay. I'm back. As to results, so we did manage to convert newsfeed in Facebook Android to do multi-threaded rendering with the help of Litho, and in a safe and scalable way with the help of Infer. The biggest lesson we learned during this process is be careful of locks, excessive use of locks, I mean. Because locks can be, in general, very helpful for thread safety to avoid conflicts and thread safety issues. But locks can also cause a thread to wait for another thread. So especially if the UI thread is waiting for the background thread to finish a thing and release a lock, it could cause a few milliseconds on the UI thread for thread contention. Or if it is too long, it could even cause an app not responding back. So here's an example of an excessive use of lock. Then this helper method, it wrapped the entire computationally expensive method inside of a global lock. So as a result, whenever the background thread is calling this method, the UI thread will need to wait for a very long time to call, if they want to call it too. So for locks in general, you need to be careful of deadlocks too. So if you have a wait logic to wait for another thread, be aware that these threads can be waiting for you to release a lock too. And so multiple locks or multiple wait logics can easily cause two threads to wait for each other forever and deadlock. That despite all the hard lessons, we did manage to achieve the converting of Facebook Android newsfeed to multi-threaded rendering with a score performance improvement. And since we minimize the amount of work on UI thread to just create a lightweight Litho wheel, mount the pre-calculated component to it and draw, we managed to avoid a lot of long frames and therefore improve the scrolling performance. For Facebook newsfeed, with fixed and optimizations, we managed to maintain a neutral crash rate with the help of Infer and then improve the scrolling performance. And we believe there's more work in progress with more contentions to resolve and additional opportunities of improvement. For a smaller and less optimized surface, we've seen up to 42% of improvement when converting to Litho. As a summary, we talk about how Android UI toolkit is not thread safe. We talk about Litho and Infer. We talk about how Litho makes multi-threaded rendering possible, and how Infer further enabled us to do a safe background rendering in a scalable code base. And eventually, we conclude with multi-threaded rendering did improve the scrolling performance. So here's all the links and references to the books and libraries we refer to. And in the end, there's also a presentation our coworker Jason gave. Here's Jason. It's about scrolling performance, and it helps give you more context about things like frames per second and frames in general. So if you are considering converting your feed to, you're considering refactoring your own feed scrolling like feed or building a new scrolling feed, try Litho out. Litho have much more functionalities and optimizations than background layouts, and is also very intuitive and easy to use. So try it out. And if you do want to improve like mobile stability or preventing thread safety issue, try Infer out. And besides thread safety issue, Infer can also actually help prevent null pointers and resource leaks. So do try those out if you are interested in improving your mobile stability. And last but not least, if you are experiencing skipping frames in your app, or you're considering reducing avoiding the low frames per second, try doing multi-threaded rendering with Litho and Infer. We sincerely hope like more of the Android world can benefit from multi-threaded rendering and achieve better user experience. So that's it. Thanks for listening. Very excited about sharing this with you guys. Time for some questions.
If you have a question, please go to the...
Oh yeah, go to the mic, please.
If you use Litho, do you have to use Yoga, or can you use one or the other and just do what you need to do?
Well, we do have a Litho expert in the audience, but I think the answer is that it's like built into the framework.
No, so I think I forgot to mention like the Infer thing is also can be used anywhere in your app, so it's not restricted to Litho code. Any other question? Not comfortable doing that?
This Litho view that you have just an empty view, it's an Android view, so it's not measured when it's go to the screen and the rendering is offline. So the size is somehow predefined, or what is the size that you render before you do it off the main thread? So is the size somehow pre-calculated, or how it works?
Yeah, the size is also so it basically theoretically it's still measured on the UI thread, but the result the measurement is actually already done is already stored in the tree of components because the tree of component is measured beforehand, and the information, the specs are already stored. So the measure is basically just grab that information. That's why we just concluded with a very small block in the UI thread.
Okay. I understand this functional definition of the UI, but is there any plan to make, or maybe it is, because I don't know it too much, to do it like a normal XML definition that you make in the background of a functional build of this view? Because we are basically using designers that design the views. Yes, we do that. And this way you have to code the views. So some bridge, is it? Yeah.
I guess one thing that can help with the fact that it's in code is to use screenshot tests, which is like a really fast way to generate previews from the code. I don't know exactly what the plan is for XMLs, but there is a cost because you have to inflate them, and that's a lot of reflection. But I think the decision was to kind of only have one system to make it simpler, but I mean, it's open source, so it's always possible
this will help for
make contributions.
The migration. I mean, you can simply start with the views that you have, basically.
Mm-hmm. Well, so Litho uses a different layout principle. It uses FlexVox. So that's going to be a lot different than what the Android views are using.
Okay, thank you.